All right. Hello, Year 11. I just would like to go over a question or some of the work we did today because I don't think, we went through it rather too quickly, I thought. So I want to have another look at question 7 for those who had a bit of trouble or haven't done this question yet. So question 7 has a whole lot. It has proving the similarity of two triangles and then using the ratio of intercepts and also the ratio of corresponding sides in similar triangles to find values. So the first thing I'm going to do is I want to draw a line. So I'm going to grab this one. I want to draw the two triangles separately. So I'm going to go and this will be the small triangle, and then underneath I'm going to do this freehand. Oh, that looks terrible, but you'll get the idea. So here we have A, B, C, and here we have A, D, E. Now, my aim is to prove that these two triangles are similar. Now, the first thing, I've drawn them separately, and I'll always beware of triangles within triangles. Now, this is going to be pretty easy because I'm going to get equal angular quite quickly. So first of all, this angle and this angle are the same because they're common. And then this angle and this angle are these two angles on the original diagram, and they're corresponding. And this angle and this angle are these two angles on this diagram down here, and they're also corresponding. And of course, here's the common one. So I very quickly get similar triangles. So I'm going to write that up because a couple of kids said they had trouble writing that up. So my prove, oh gee, my handwriting's shocking with this pen. Triangle ABC is similar to triangle ADE. And we just write everything about the triangle ABC on the left and everything about the triangle ADE on the right. So A or B, AC equals DAE. Well, it's the same angle. So I'm just going to write it's common. And ABC equals ADE. It's corresponding angles, and BC is parallel to DE. And finally, and I only need two because it's equal angular. As soon as you have two, you have three. But ACB equals AED. I've got my ing here. That's terrible. Corresponding angles BC parallel to DE. Therefore, triangle ABC is similar to triangle ADE. Now remember, you can't use acronyms, but you can say equiangular. So your proof's done. Now that the triangles are similar, let's just write some things on here. This is over, that's 1.5. That's X, and that's Y. And this is 1.5 plus 0.9, which equals 2.4. And this is 3.6. We don't even need the other side. So the first one, let's find the value of X. Well, X is a little bit separate. If you look here, X is ratio of intercepts. So it's a ratio of intercepts. It's going to help us find this one. And as I said, always put the pronumeral on top. X on 1.3. So this to this equals this to this. They're in ratio, and that equals 1.5 on 0.9. So X equals 1.5 on 0.9 times 1.3. And X equals 2.16 repeater. And the back of the book has that as 2.17. Oops, I'll write that a bit neater. So that's a ratio of intercepts with parallel lines. The other one, to find Y, uses corresponding sides in similar triangles. So Y, if we look up here, Y corresponds to 3.6. Y in the small triangle corresponds to 3.6, which equals 1.5, because the sides are in ratio to the big side. And this is an important one. It's 2.4. It's 2.4. 2.4. Once you've written that, you just multiply the 3.6 over 1.5 times 3.6 over 2.4, which is 2.25, which is the answer. I'm pretty sure. What are the measurements in? They don't tell us. And so I'm pretty sure that one's correct, that one's correct, and up here, that one's correct, equiangular. So similar triangles, beware of smaller triangles in large triangles because they're incorporated. And here we've got ratio of intercepts on parallel lines for finding X. And here, in this one, we've got corresponding sides in similar triangles, a little bit different.